here is that technology can work to solve a business problem, a real need that we're seeing. And as per the introduction, I'm not talking about some science fiction. This is working. This is working in production today. You see some of the leading players, and you see them across multiple industries, whether this is aerospace, wind energy, automotive, etc. And this is not the future, or rather the future is here. Consider also our partnerships. I'll talk also about our work with Google and others. There's an ecosystem. There's a group of companies that are moving together in this field, collaboration, and also our partnership with CPC in Stade, the AMRC and the University of Sheffield. This is groundbreaking technology, but the good news, it's already being put to good use. So, what's AI? And I went to the dictionary. It's always the easiest form. And apart from the buzzwords, it's a branch of computer science, really, that's all it is. Mathematics, computer science, operation research, and the ability of a machine to imitate human behavior. Well, that's pretty simple. Of course, it begs the question, what's intelligence to begin with, and how do you judge that? We'll talk about comparing AI and what makes a better solution than others. But this is pretty straightforward. Now, I'm not talking about the, Arnold Schwarzenegger, the Terminator taking over the world. That's what's called often strong AI. We're not there yet. It's not the issue. We're actually talking about something a lot more concrete. In our world, it's the business world or manufacturing world, and that's what I really want to focus on. And the issue here is the, how do we define it? And I want to use this example. Let's use the common word here, digital assistant. Our goal here is to develop intelligent digital assistants that help the users, help production floor management, production floor staff do a better job. I always like to bring this example from our day-to-day life as consumers. We have a navigation app. I'm pretty sure all of you are using it. It's connected. It's solving a problem. How do I get from point A to point B? It's very dynamic, and it's very useful. So consider this in mind as a good example for a digital assistant, and let's talk about how this all fits into a manufacturing environment. A lot of times we go to our clients or partners, and they will say, well, we already have AI. We have a dashboard. This is a dashboard. How many of you are familiar with Waze navigation app? On our phones. Yeah, it's a Google application. We can use it on our phones, but if you go to the web page, you do waze.com, you can type in any city. Those of you recognize Paris behind me. It shows you a map of Paris. It shows you all the alerts and bottlenecks and problems and traffic jams. This is a dashboard. It's beautiful, by the way, a lot of colors. Now, in order to make this useful, what do you need to do? Well, you need to be looking at it all day. You need to be an expert. You need to understand what you're looking at. So you need to understand Paris. You need to understand driving. You need to understand driving in Paris. But more than anything, if you need to get from point A to point B, you need to solve the problem. That's a lot of human intelligence. It's not a lot of artificial intelligence. What these navigation apps are doing very well in our phone, they're not giving us a dashboard. They're giving us instructions. Turn left, turn right, get off the highway. You didn't even know there was a problem. You did not realize there was a bottleneck on road number 5, and then you were now shifted to road number 2. And that's the beauty of these apps. That's what makes it so useful. And we'll also talk about the human-machine interface later. But the point here is that we do not want to show the users data. We want to show them actionable insights, something useful that helps them do a better job. Let's take a deep a dive into history. A lot of the AI talk now is around deep learning. And this is by NVIDIA. Kind of history here, if you look back even to the 70s or even before that, the big AI promises and a lot of research, some early success, and then the whole thing kind of fizzled in what scientists may now call the winter of AI. But winter is coming and it's back. About 5-10 years ago, there were a lot of big breakthroughs by companies like Google and then Alibaba and Amazon and Microsoft and many others, really formulating very powerful tools around machine learning, or what's more known now as deep learning. That represents a big problem. It also has limitations. I'll mention this later. AI is not just machine learning, but this certainly created a big boom. Here's a classic example. Some of you may have seen it and probably already using it around predictive maintenance of tooling, of machinery, etc. This transition from reactive maintenance, break fix, to plan, to predictive is really the end game. And of course, this serves for machine downtime, reduction, and higher throughput, etc. But the point here is we're collecting a lot of data, and then the computer can learn this data and can now recognize patterns and predict failure. So this is a very practical example. We see this a lot, and it's very useful. We see similar use cases, by the way, around the defect and quality issues. So these are very useful as well, composites and otherwise. Keep this in mind. Remember, this tells you you have a problem, but sometimes you want to go beyond that. So again, not to go too deep into the mathematics here, what does deep learning do? It's a big name. It takes a lot of data, and it goes through it and scans for patterns. And the patterns may tell us that a given problem is going to occur, that this defect is actually a defect or nothing else, or vice versa. And this is actually very important. But in order for this to work, we need a few things. We need a lot of data, we need a lot of computing power, and we need time. Now, computing power is not an issue today. Data in real life is. We see a lot of deep learning applications in the consumer space, pictures, image recognition, Facebook, and all these guys. They have a lot of data. Those of you that are coming from the manufacturing floor will soon say, wait a minute, we don't always have the data, or it's very hard to reach, or it's not clean. And these are challenges. These are challenges that are inhibiting this technology. But if you think about it, it doesn't also solve what we call the complete workflow. And I will explain that as well. So there's a big room here for other technologies, other AI technologies, but also a lot of human involvement and domain expertise. Now, we're talking about very advanced technology, but one of the key, I guess, messages today is that the technology is cool, but we're really talking about solving problems. This is not my quote, this is someone a lot smarter. But at the end of all this, starting with a problem statement is critical. Then you know which data you need, then you know which technology, application, algorithm to apply. And it's actually very critical. In our experience, we see a lot of companies adopting AI, really not sure what they're trying to do. Someone in the board said, oh, we got to do AI. Okay, great. Now what? So always start from the problem. What are we trying to solve? Is the issue machine downtime, tool maintenance, material utilization, quality issues, and work back, and then find the right solution. But consider this is true for everything in life. Somehow in today's discussion, with all the excitement, people miss this important step. Now, when we talk about solving a business problem, or any problem at all, we need to think about the full workflow. And this is where a lot of the recent applications are actually limited, and we want to push the envelope. And this is really our goal at Plataine at our company. When you go to a doctor, the doctor does three things. He or she will do diagnosis, what's happening. He or she will then do prognosis, what's going to happen. This is going to get better, this is going to get worse. But what a good doctor does today, they actually apply treatment. You do not go to a doctor and expect a doctor to say, sorry, you're sick, goodbye. It just doesn't work like that. And the same must apply for business systems, and certainly this is one of the biggest opportunities of applying AI. AI now is in a proven position not only to understand what's going on, but actually to predict and apply the optimization. So this material is going to expire. Okay, thank you very much for your prognosis, for your alert. But what do I do about it? Well, the solution is take this material to that job on that machine before 2 o'clock, and everything will be fine. Consider this also to the navigation app, the Waze analogy. It's not just telling us that there is a traffic jam. It's actually rerouting us and doing so in real time. Now, our ability with AI to actually address this full workflow is critical. It creates business value that far exceeds just solving part of the problem. The dashboard tells us what's going on, but gives us really nothing to do with it. Alerts are wonderful. We are about to have an issue. This is a bottleneck. This is going to fail, but we want to give a solution. So how do we do that? The first step is data collection, okay? And we need data. And the data we see in composites in our industry comes from three main sources. The enterprise systems, the ERP, the PLM, the MES, they have a ton of data, horribly underutilized, not used enough. IoT, machines create a lot of data, sensors create a lot of data. So IoT is a massive enabler for AI. And that's really where we need to put it. Data collection for the sake of data collection, of course, is not very useful. And still, in our industry, there's a lot of room for human interaction. This is not the food and beverage industry or semiconductor industry where we have lights out factories. So we want to get data from the operators, from the supervisors. It's actually extremely useful. You take all the data and you put it in context. Context is an AI term for context awareness, but also is simple English. Why does context matter? Because data alone is really insufficient. If we know that a tool is right here in this room, well, is it good or is it bad? The MBA answer, it depends. If the production schedule and the bill of material and the status of the tool, if they all tell us that this tool needs to be here right now, great. If they tell us that this tool needs to be in hall number 5, not great. So knowing the data alone is insufficient. You need to put the data in context, and then you're able to trigger the alerts, make the prediction, or make the recommendations, the optimization. Now, the more data we have, the richer the context. But I also want to say that a little data is better than no data. So there's always the opportunity to start with something. And don't fall into the trap of saying, oh, we need a lot of data and it's going to take us a year to get it, and before a year passes we can't do anything. That's simply not true. So get going, get the data, and get to work. And then comes the scary AI and the revenge of the machines and what's going to happen to us people and our operators. I've seen a lot of concerns about that, but really the reality is simply different. Especially in this environment, the complexity of the environment, the nature of ramping up. What we're really seeing here is that AI pushes the envelope. It creates a better man-machine team. The dependence on the user's skills is reduced. We are relieving the user of a lot of mundane tasks. The user, highly experienced, highly educated, is now available to do more important things. So as a whole, this team is doing a better job than any one of them alone. This is important. The team does a better job than the human, but the team also does a better job than the software alone. So the software in many cases will not completely replace us, rather give us a better tool to do a better job, faster, higher rates, more complexity, and this is even before we start talking about the new materials that are coming out and expected in the next 5-10 years, which are even more complicated to handle. So we put the system in place, and now we have these apps in the hands of users. They've been working for 10, 20, 30, 40 years, and we need to earn their trust. Because the AI is making predictions, and the AI is making recommendations, but at the end of the day, there's a user there that has to trust it and accept it. If they don't, then we've done nothing. If we recommend to use this tool for that job, or if we recommend to take that material out of the freezer first, that's probably a good recommendation, but eventually, when the user is there, to override it. How do you earn trust? Like any good relationship, it takes time. And you need to show that you're doing something that is at least as good as what this person has done alone. Taking you back to the navigation app, how many of you thought you were smarter than the navigation app? I told you to turn left, and you thought it's better to turn right. It's okay, don't be shy. Now, it happens. And the first time it happened, you probably realized you made a mistake, and after another time or a third, eventually you learn to trust the software, assuming it's good, assuming it's bringing value. And that's also our experience. We deploy these systems in production. There's an element of change, there's an element of training, but eventually we're talking about very experienced users that have been doing this forever. And then they see the value, they see how it helps, and they're on board. The last one is about autonomy. I get this question a lot. So, wow, the software is now going to drive my factory and do what it wants, and Fukushima and all that. So, not necessarily. A good way to evaluate this is on simple parameters of time and cost. Do we have time or not for the software to make a quick decision without the human override? But also a question of cost. Yes, technically speaking, the software can shut down a production line. Shut down the machine. The machines are robots. But what does it mean to shut down a machine? It will stop the production line. It means a lot. But what does it mean not to shut down the machine if it's about to have a massive quality issue or a safety issue? So these are questions of cost, benefit, and risk that are easily quantified. Again, very practical. Don't go into all these philosophical questions about software autonomy or AI autonomy. This is a technology, it has a business use, and you can weigh it very practical. So now you have two applications. They're both AI. How do you compare the two? Well, what application is better than the other? So we developed this approach really to say that it's actually comparable. And we want to compare the two applications on two axes of automation and intelligence, the quality of the output. Some applications are very smart, but they're manual. They require a lot of manual intervention, typing in, etc. That's good. Some applications are very fast, very automatic, but they're not very smart. So that's not good, typically. This is where we want to be. We want to be highly automated and highly intelligent. The more of these decisions we can do, more intelligent, faster, less human involvement, the more value we produce. So when you compare two applications, ask yourselves where they are on this quadrant and which one is better than the other. If two applications are the same in terms of their intelligence, the quality, which one is more or less automatic, and vice versa. And of course, at the bottom, you see something that's not really AI. It's not automatic and it's not intelligent, but guess what? This is where we find Excel, #1 software in the world. So we see a lot of Excel in manufacturing sites. It's there. It's typically some improvisation. But don't confuse that with the actual application of AI. Zero automation, zero intelligent or computerized decision making. Just an example here, it's the alerts on the production floor. There are sensors on materials that tell us what's going on. The software knows the production schedule. The software knows the bill of material. The software learned from past history that some processes in given situations can take longer than expected. So the software is making a prediction. If you use this material for that job, you think it has enough shelf life. You have 50 hours. But based on past history, this job is going to take 60 hours. So you need to use a different one. So learning from history, the actual situation assessment, prevents the use of disqualified material even before you start. Eventually, this is what it looks like. Different people on the production floor using different alerts, using different applications, getting messages, instructions, recommendations, alerts. It's all connected. The decision of one user may impact another, and continuously feeding with more data, the context is changing, more decisions are being made, more alerts are escalated, more action happens, and the context changes yet again. This is working all day. Just to finish on our work with Google, we've actually integrated with Google, taken our specific AI capabilities and working with their generic ones. So Google Glass is a wearable, it's a user interface. What's more interesting here is to develop a dialogue using Google's ability to understand natural language. So the user now asks questions. There's a microphone. Where is my material? Which job should I do next? Which tool should I use for which job? This is being translated, then going to the AI engine in the background, hours, and then the user gets a result, gets an answer, as if he's talking to an expert or supervisor standing right next to them. So this was just announced in the summer at the Google conference. But the point here is not the Google Glass. The point here is the interaction, the ability of the user to ask questions and get intelligent answer as if they have this digital assistant, their supervisor, behind their back, helping them during the day. Of course, not just for junior employees, also for the expert. So with that, thank you. I think we have some time for questions.
No, sorry.
Sorry, okay.
Yeah, but
So,
after we have a break, so we have the last presentation, and then the lunch, you can discuss doing so much. Sorry.
no problem. So thank you very much for your time, and here's my contact information. Happy to take questions later.